There's this invisible science that secretly connects almost everything. It's a hidden force that dictates how a jumbo jet soars through the sky and why your ketchup gets stuck in the bottle. It governs everything that flows, from the weather patterns on our planet to the blood pumping through our veins. So let's pull back the curtain on this secret world of fluid mechanics.
I know, right? It sounds like the setup to a really weird joke, but the answer is amazing. It links your dinner table to the stratosphere and reveals a fundamental science that you are interacting with, well, every single second of every single day.
That's it. Fluid mechanics. It's the science of, you guessed it, things that flow. And once you start looking for it, I'm telling you, you're going to see it absolutely everywhere. So to really get a handle on this, we've got to start with the most basic question of all. What even is a fluid?
Well, sometimes to understand what something is, it helps to look at what it's not. Think about a solid, like a brick. Its molecules are locked together in a tight grid. If you push it, the whole thing moves as one piece. But with a fluid, well, the molecules are way more relaxed. The bonds between them are weaker. So if you apply a force, it doesn't just move, it flows, it changes shape, it deforms.
So it all boils down to this really simple but incredibly powerful definition. A fluid is just anything that can flow. Now, this obviously includes things like water and air, but it also covers some stuff you might not expect, which, hey, brings us right back to that stubborn bottle of ketchup.
Come on, we've all been there. You're tapping the bottle, you're shaking it, waiting, nothing. And then, whoosh, a tidal wave of red all over your fries. This isn't just a quirky design flaw. It's actually a fascinating lesson in fluid properties. The secret has a name.
Viscosity. You can think of it as a fluid's thickness, or maybe its internal friction. Water, for example, has really low viscosity. It flows easily. Honey, on the other hand, has a super high viscosity, so it flows very slowly. But ketchup is special. It doesn't play by the normal rules. And here's the cool part. See, water is what we call a Newtonian fluid. Its viscosity is always the same no matter how much you stir it or shake it. But ketchup is non-Newtonian. It's something called shear thinning, which is a fancy way of saying its viscosity actually drops when you apply force. So it just sits in the bottle, all thick and stubborn, until you shake it. That force makes it thinner, and suddenly it all comes rushing out. And this isn't just a neat little trick for your next barbecue. This whole principle of changing viscosity and fluid mechanics in general is one of the great unsung heroes of our daily lives. It starts working for you from the second your alarm goes off. Seriously, from the moment you open your eyes, you are literally surrounded by complex fluid systems, all working behind the scenes to make your life easier and more comfortable. Think about it. That cool breeze from your AC, that's thanks to a coolant flowing through its system. The water coming from your tap, it just traveled through a massive, complex network of pipes. Even your fridge is in on the action, constantly circulating coolant and air, all fluids to keep your food from spoiling. Okay, so breakfast is done, it's time to head out. And it doesn't matter if you're in a car, on a bus, or even on a train, you are, once again, whether you know it or not, putting your complete trust in fluid mechanics. An engine is basically all about the perfectly timed flow of an air and fuel mixture. And the brakes that keep you safe, they work because hydraulic fluid, which can't be compressed, transfers force instantly from the pedal to the wheels. Even the sleek aerodynamic shape of your car is designed to master the flow of air, cutting down on drag. The applications just keep coming. Let's look at a couple of other common pieces of tech you probably use without giving them a second thought. Ever print something out? That's the result of incredibly precise control over tiny droplets of ink flowing exactly where they need to go. And when you clean your house, your vacuum cleaner is a perfect little fluid dynamics machine, creating powerful suction by moving huge volumes of air. So we've seen how fluid mechanics is in our food, our homes, our cars. It shapes our personal world. But the exact same principles that make ketchup flow are also at play in some of the most awe-inspiring feats of modern engineering. The scale gets massive. And it all starts with this legendary idea from way back in ancient Greece. The genius Archimedes figured out that when you stick something in a fluid, the fluid literally pushes back. We call this upward push buoyancy, and it's the reason a gigantic steel ship can float on water. It's such a simple and elegant concept. An object goes into a fluid and pushes some of it out of the way. The fluid then pushes back up with a force that's equal to the weight of the fluid that got moved. If the object weighs less than that upward force, it floats. Simple as that.
And engineers take this understanding of buoyancy and fluid pressure, what they call hydrostatics, and use it to build structures that can fight back against almost unimaginable forces. I mean, just look at the Glen Canyon Dam. The pressure at the bottom of that massive reservoir is just immense. The reason the dam has that specific curved shape isn't just for looks. It's a masterpiece of fluid mechanics. It works like a giant arch, perfectly channeling the incredible force of all that water away from the center and into the solid rock of the canyon walls. Okay, so we've journeyed from Ketchup to cars to absolutely colossal dams. But to really, truly appreciate the scale we're talking about here, we need one last very important number: 75%. 75% of our entire planet is covered in a fluid. And that's not even counting the fact that the whole world is wrapped in a 100-kilometer thick blanket of another fluid, our atmosphere. The scope is just staggering, which is why understanding these principles is so critical. So from now on, whether you're watching the swirl in your morning coffee or just looking at the clouds drifting across the sky, you'll know you're seeing the invisible science that connects it all. It's a pretty cool reminder that even the most ordinary things are governed by some truly extraordinary principles.